Good morning, one and all. Let me welcome you all for this class. So today we are going to discuss about third unit, that is pure substances. So why we need to study pure substance means so the application of pure substances will be many. Like for example, in thermal power plants, steam is used as thermal power plant. Steam is used as a working fluid. So we need to study the properties of steam. That is, steam is one pure substance. So like that, the applications of pure substance will be having many. So that's why it is very important to study about the properties of the working fluids, that is pure substances. So once we know working fluid properties, then only it is possible to estimate the properties of any thermal system, any power plant, any device which is operating with a pure substance. So let us see what is meant by pure substance. A pure substance is a substance of constant chemical composition throughout its mass. So a pure substance is a substance of constant chemical composition. So through its mass is considered as one pure substance. It is one component system. It is one component system. It may be exist in one or more phases. So there are three phases with that: solid, liquid, water. I mean vapor phase will be there. So that can be exist in any phase. A substance that has a fixed chemical composition throughout is called as pure substance. So one more definition is a substance that has a fixed chemical composition throughout is called as pure substance. Next one is a pure substance does not have to be a single chemical element or compound. It may be single element or it may be compound. However, a mixture of various chemical elements or compounds also qualifies as a pure substance. It may be one or it may be a combination of number of chemical elements. So that and as long as the mixture is homogeneous, as long as the mixture is homogeneous, then it is termed as pure substance. A mixture of liquid and water vapor is a pure substance, but a mixture of liquid and gaseous air is not pure substance. So, if you take any working fluid, its chemical composition is uniform throughout the working fluid. So then the working fluid is termed as pure substance. Pure substance. So generally that water vapor and water will be there, no? In majority of the cases, we are using water as a working fluid. Therefore, best example for working in pure substance will be water only. So when you supply heat to the water, it is converted into steam in liquid, and after vapor phase will be there. So the examples for pure substances will be: one is water. It is in the different forms like solid, liquid, and vapor phase. Next one is mixture of liquid water and water vapor. So generally in mixture of liquid water and water vapor is also termed as pure substance. Generally this is called as atmospheric air. Next one is carbon dioxide. If you take only carbon dioxide, so the composition of the carbon dioxide is throughout uniformly in it. Nitrogen also it is called as one pure substance. A mixture of gases such as air, as long as there is no change of phase. So a mixture of gases. If you take gas, gas is a mixture of so many gases. I mean, air is a mixture of so many gases. So that is also treated as one pure substance. So that is the definition of pure substance. So have you understand your what is meant by pure substance, Teja?
Yes, sir.
Yeah, no. Today I will explain with help of this material. Tomorrow, with help of pen and board, I will once again discuss the pure substance. Okay.
Okay, sir.
Yeah. Now coming to the phases of pure substance, generally we know three phases will be there. The substance exists in different phases. Example: room temperature and pressure. Copper is solid, and mercury is liquid. So it can exist in different phases under variation of conditions. So generally the phases will be: one is solid, liquid, so next one is gas. These are the three phases where so pure substance will be existing. So in case of pure substances, generally we come across saturation condition. Generally we come across saturation condition. So let is what is meant by saturation condition, we will see. So saturation is defined as the condition in which Mixture of vapor and liquid can exist together at a given temperature and pressure. So saturation condition means it is defined as a condition in which mixture of vapor and liquid. Generally, it will be happen at boiling point temperature. Boiling point temperature. For example, at atmospheric conditions, if water is heated to 100 degrees centigrade, so here there water will be converted into steam. So that condition is called as saturation condition. So saturation is defined as a condition in which mixture of vapor and liquid can exist together at a given temperature and pressure. Saturation pressure means the pressure at which saturation pressure means is the pressure at which liquid and vapor phases are in equilibrium at a given temperature. So here liquid and vapor phase will be equilibrium condition at a given temperature. At a given temperature. So next one is for a pure substance. For a pure substance, there is a definite relationship between saturation pressure, saturation temperature. The higher the pressure, higher the saturation temperature. That means boiling point. Pressure is high means boiling point is high. If pressure is less means boiling point will be less. So if a substance exists as a liquid at the saturation temperature, if a substance exists liquid at the saturation temperature and pressure, it is called as saturated liquid. It is called as saturated liquid. I repeat, if a substance exists as a liquid at the saturation temperature and pressure, it is called as saturated liquid. So that means for at 100 degrees centigrade and atmospheric conditions, so water will be starts boiling. That is, steam will be produced. Therefore, 100 degrees centigrade is called as saturation temperature. So 100 degrees centigrade is called as saturation temperature. So for that condition, the pressure is one bar atmospheric pressure, that is 1.013 bar. That is termed as a saturation pressure. Saturation pressure. Okay. Next one is if a temperature of the liquid is lower than the saturated temperature of the existing pressure, it is called as a subcooled liquid or a compressed liquid. Subcooled liquid or compressed liquid. For example, at atmospheric conditions, if water is heated to 100 degrees centigrade, then evaporation will be takes place. Therefore, 100 is called as a saturation temperature. Suppose if you heat water up to 80 or 90, so then the condition of the liquid is called as a subcooled liquid or a compressed liquid. Then the liquid is called as subcooled liquid or compressed liquid. So next one is go to next one. If a substance exists entirely as a vapor, if a substance exists entirely as a vapor at a saturation temperature, so it is called as a saturated vapor. Suppose if water is completely converted, if water is completely converted into, if water is completely converted into vapor at 100 degrees centigrade at atmospheric conditions, then that steam is called as a saturated vapor. That steam is called as saturated vapor. Next, one more condition is there. When the vapor is at a temperature greater than the saturation temperature, it is said to exist in a superheated vapor. Suppose at atmospheric conditions, saturation temperature is 100. So you have taken one vessel. In that vessel, water will be available. Suppose if you heat water to the 100 degrees centigrade, that is called as saturation condition. Suppose if you heat water more than 100 degrees centigrade, let us say 120 or 200 or 300, something like that. So then in that case, the condition of the steam, the temperature will be more than 100. So the condition of steam is called as superheated vapor. So any vapor whose temperature is more than the saturation temperature, then it is treated as superheated vapor. Superheated vapor. Superheated vapor. Generally in boilers, no. So we are having superheated vapor, and boiler also called as critical boilers, where vapor will be heated to more than 300, more than 400 also. That depends upon the application they are required for. So that depends upon that is called as critical boiler, not common boiler. It is called as supercritical boiler. Supercritical boiler, where water will be get heated to more than 100 degrees centigrade also. Okay. Next one is the pressure and temperature of superheated vapor are independent properties. So when you superheat the vapor, here up to saturation condition, there will be a relation between pressure and temperature will be there. But after a superheat condition, they will become independent since temperature may increase while the pressure remains constant. This is the reason pressure lines will be different and temperature lines will be different after superheating. I mean, before at the superheating condition, at the starting of the superheating condition, or at the on I mean uh, in superheating condition. Next one is we are cutting different terminology. The different terminology is one is latent heat. Generally, we come across all this terminology in case of heating of water. First one is latent heat. So latent heat is nothing but the amount of energy absorbed or released during a phase change process. Phase change process means so liquid to vapor or vapor to liquid. Next, solid to liquid or liquid to solid. So the amount of energy released or the amount of energy absorbed is called as latent heat at a particular temperature, at a given temperature. So here we are having two kinds. One is latent heat of fusion, and next one is latent heat of vaporization. So we will see what is meant by latent heat of fusion. So latent heat of fusion is nothing but the amount of energy absorbed during melting, or it is also equivalent to the amount of energy released during freezing. Amount of energy released. Let us say an example, ice. So ice at zero, suppose it is start melting. Ice at zero starts melting means so the amount of energy absorbed during melting, the amount of energy absorbed during melting, no, that amount is called as latent heat. That is amount of heat supplied to the ice, so that the ice is melting at zero. So that amount of heat is called as latent heat of fusion. So in other words, the amount of energy released during freezing of ice. Generally, we are keeping water in a glass in a fridge in homes. No, the refrigerant water what it takes, no, it will remove the heat from the glass. So the amount of heat removed from the glass at zero in order to form ice at zero. So it is termed as latent heat of fusion. So this is in between solid to liquid and liquid to solid. Next one is comes to latent heat of vaporization. So latent heat of vaporization will be the amount of energy absorbed during vaporization, and it is equal to the energy released during condensation. So generally, at atmospheric conditions, water will be boiled at 100 degrees centigrade. Water will be formed into vapor. So the amount of energy supplied to the water, so that or amount of energy absorbed by the water, so that it is forming vapor. So the amount it is called as latent heat of vaporization. So in other words, suppose if condensation is happening, so the vapor will be condensed into liquid. So the amount of heat removed from the vapor at 100 degrees centigrade. So that heat is called as latent heat of vaporization. So water is a very standard fluid. Water is a standard fluid. Therefore, at atmospheric pressure, the latent heat of fusion will be 333.7 kilojoules per kg, and latent heat of vaporization is 2256.5 kilojoules per kg. So these are the very standard values, or these are the very common values. Everyone has to remember this value. Everyone has to remember this value. So latent heat of fusion will be at 0 degrees centigrade will be 333.7 kilojoules per kg, and latent heat of vaporization, that is at 100 degrees centigrade and atmospheric conditions, will be 2256.5 kilojoules per kg. Everyone has to remember these values because water is a common fluid, a standard fluid, and these are the standard values. No need to refer any standard book. Okay. Next one is coming to when a substance exists as a part of a liquid and a part of vapor at saturation condition is uh, at saturation conditions. Therefore, its quality is defined as the ratio of mass of vapor to the mass of both vapor and liquid. So generally we are producing steam. So in case of steam is a working fluid in case of many thermal systems, especially in case of thermal power plant. Steam is a working fluid. Steam is a working fluid. Therefore, the quality of the steam can be defined in terms of one index that is called as dryness fraction. That is called as dryness fraction. So therefore, dryness fraction is defined as uh, when a substance exists a part of liquid and part of vapor at saturation conditions, its quality X is defined as the ratio of mass of vapor to the mass of both vapor and liquid. It is termed as dryness fraction. Generally, the quality is zero for the saturated liquid. And for the saturated vapor will be one. Therefore, any steam, the Dynex fraction will be lies between 0 and 1. Minimum value will be 0 and maximum value 1. So in between 0 and 1, the Dynex fraction will be lies. So Dynex fraction is nothing but the ratio of mass of vapor, that is amount of vapor which is present in the liquid and vapor mixture, that is present in the you can say steam, liquid and vapor stream, no, or steam. So that is X is equal X. Generally, it is denoted by X. Generally, it is denoted by X. X is equal to mass of saturated vapor. Mass of saturated vapor divided by total mass. So generally, vapor is denoted with G, mg by mf plus mg, mg by mf plus mg. Okay. Next one is for example, mass of vapor is 0.2 grams and mass of the liquid is 0.8 grams. Therefore, the dryness fraction for this case will be mass of saturated vapor will be mg is zero point 0.2. Zero point 0.2 divided by mf will be 0.8 and mg will be 0.2. Therefore, the ratio will becomes zero point 0.2 by zero point 0.2 plus zero point 0.1. Then the value will becomes uh, zero point 0.2 by 1, zero point 0.2, or in percentage it is 2. It is 2. So the dryness fraction is 0.2, zero point 0.2, or in percentage I think it is 20%, not 2, it is 20%. Okay, like this we are finding the dryness fraction of a steam. Next one is we are having properties of steam. The property table will be generally in order to we need to solve the problems on pure substances. For that, the properties will be available in the steam tables. Steam tables. So in steam tables, you will have the properties of steam at different conditions. At different conditions. So I request all of you to purchase or download any steam tables book so that it will be easy to solve the problems on pure substances. Pure substances. So let us. I will show that steam table book how it is. I will show you so that you can understand the importance of steam tables book now. So I will go. I will go to the sharing. Teja, first time you are coming across steam tables, no? Teja, Lokesh,
Sir,
first time you are coming across this steam tables, no?
yes, sir.
Have you seen I mean, these steam tables previously, ma? So we are having stream tables like this. We are having stream tables like this. So in stream tables, so different authors will be there with molecular diagrams, SI units, everything will be there. So this is the author R.S. Courtney. So like this, so many authors will be there for stream tables. So if you take any stream tables, the procedure is same only, the values will be same only. You can choose any author. Publication will be S. Chand. So if you open the stream tables, So here you will get the contents and all these things. You will get contents and all these things. The contents are, I will show that contents. So here, if you see the index and all these things, you will get. So if you see the index and all these things, you will get. So introduction to steam tables and molar diagram, saturated water and steam tables, saturated water, steam pressure temperature tables and pressure tables, specific volume of superheated tables, superheated tables and superheated tables. So one is based on temperature, one is based on pressure. You will get the steam properties. Will be other three graphs are other three graphs are superheated condition. Other three graphs. So let us go to the steam tables. So here you will get at or at 0 degrees centigrade. What are the properties of steam? In properties of steam, like that you can go for at every temperature. You go to the 100 degrees centigrade. So you go to the 100 degrees centigrade. The pressure is 1 point, saturation pressure will be 1.0133, and specific volume of the liquid, specific volume of the gas, enthalpy of the fluid, latent heat of the, means that steam, and enthalpy of the gas, entropy of the fluid, entropy during phase change, entropy of the gas, and finally you will get the saturation temperature. Like this, you will get the, when temperature is given, we can predict the properties of the given steam. We can give this one. Similarly, pressure tables will be given. When pressure tables are given, so here with respect to pressure, we go to the 1.01225. This is the atmospheric pressure. So at atmospheric pressure, the temperature, saturation temperature is 100 degrees centigrade. So if you increase the pressure, boiling point will be increasing. If you decrease the pressure, the boiling point will be goes on decreasing. The point will be goes on decreasing. So at 1.03125, you will get the all the properties of the steam. This is about the pressure tables. Next one is we are having superheated condition. In superheated condition, so we are this will be superheated. For specific volume separately, we are having a one table. That means pressure will be given, temperature will be given, saturation temperature. So 100. Next one is 150, 200, 250, 300, 350, like that. For every temperature, so you will get the properties of the given stream. You will get the properties of the superheated stream. This is for a specific volume. Similarly, you will get enthalpy also. This is for a enthalpy of superheated stream, and also entropy also you will get. Similarly, entropy, for entropy also, entropy of superheated stream. So like this, for every property, you will have the separate chart. For every property, you will have the separate chart. So this is called as steam tables. The cost will be around 40 rupees only. Otherwise, I will share this book to you. You can practice the things. Okay. So coming to next topic, what we are discussing, properties of steam. Properties tables now. If the answer to the first question is yes, the state is the compressed liquid region, and compressed liquid is table is used to find the properties using saturation temperature. So here, if the given volume, if the given volume is less than the volume of the fluid, so if the given volume is less than the VF, then the condition of the then the condition of the steam will be compressed liquid or subcooled liquid or subcooled liquid. Next one is if the answer to the second question is yes, the state in the saturation region and either the saturation temperature table or a saturation pressure table. Suppose if VF will be lies, if VF will be lies between VF and VG, then we are referring to the saturation condition. Then we are referring to the saturation condition. Next one is if the answer to this question is yes, if state is the superheated. Suppose if the given volume is greater than the volume in VG value, then the condition of the steam will be superheated. Then the condition of the steam will be superheated. So like this, based on the given volume, and we are getting the at the given pressure, we are getting the Vf, Vg, and Vg from the steam tables. If the given value V, if the given value V will be lies in between Vf, Vg, it is called as saturated steam. If it is greater than Vg, it is termed as it is greater than Vg, it is termed as superheated steam. It is less than EVF, it is termed as subcooled liquid. So like this also we can define condition of the steam. Next one is there are some of the important definitions will be there. One is critical point. So the temperature and pressure above which there is no distinction between liquid and vapor. There is no distinction between liquid and vapor. So that is termed as a critical point. Next one is triple point is there. The temperature and pressure at which all three phases can coexist in equilibrium. The temperature and pressure at which all three phases coexist in equilibrium, that is called as triple point. Next one is there are different lines will be there. One is sublimation. Sublimation means a change of phase from solid to vapor directly. Vaporization, change of phase from liquid to vapor. Condensation, change of phase from vapor to liquid. Fusion, melting, it is also termed as boiling, change of phase from solid to liquid. So fusion means, sorry, melting means evaporation is termed as boiling. Fusion or melting means change of phase from solid to liquid. So these are the different phases and the terminology we are using. Next thing is one they have explained the PV diagram. I will explain this PV diagram later part. So I will stop here. This is the PV diagram actually. We will discuss all these things in the next class. You can ask me doubts. I will clarify up to now. Teja, any doubts you can ask me. I will clarify. This is the phase, PV diagram of water. Any doubts, no? Teja will ask doubts on doubts. That's why I'm waiting for it. So I once again repeat for the sake of all the people, those who came later. What is pure substance? A substance that has a fixed chemical composition throughout. A substance which has a substance that has a fixed chemical composition throughout is termed as pure substance. Air is a mixture of several gases, but it is considered to be a pure substance. Even the air is containing so many constituents, it is termed as one pure substance. Nitrogen and gaseous air are pure substances. Nitrogen is termed as a pure substance because it is chemical composition throughout it is same. Next, air is a pure substance because chemical composition is same throughout the air. A mixture of liquid and gas water is a pure substance, but a mixture of liquid and gaseous air is not. So, no, mixture of liquid and vapor will be a pure substance, whereas a mixture of liquid and gaseous air is not a pure substance because there are different phases and the chemical composition will be different throughout. Next one is the arrangement of atoms in different phases will be molecules are relatively fixed positions in solid, whereas groups of molecules move about each other in liquid phase. and molecules move about randomly in gaseous space. Therefore, coming to the compressed liquid, it is I told you, coming to the compressed liquid, it is also termed as subcooled liquid, a substance, a substance that is not about to vaporize. It is termed as subcooled liquid. That means a liquid, we mean a liquid which is heated up to 90 or 80, not 100 or more than 100, then it is termed as subcooled liquid. Next one is saturated liquid, a liquid that is absolute or to vaporize. If you heat the liquid to its saturation temperature, then that liquid is termed as saturation liquid. So the vapor which is present at saturation condition, that is at boiling conditions, that is termed as saturated vapor. The vapor that is about to condense is called as saturated vapor. Next one is saturated liquid vapor mixture. The state at which liquid and vapor phase exist in equilibrium. So that state is called as saturation condition state, or it is also termed as a saturated liquid vapor mixture. Next one is we are having one more vapor, that is superheated vapor. A vapor that is not about to condense is called as superheated vapor. So in case of superheated water, superheated water, it will be heated more than 100 degrees centigrade. See these examples, you can understand what is the difference between different cases. First case will be at atmospheric conditions and 20 degrees centigrade, water exists in the liquid phase. So the condition of the liquid is called as compressed liquid. It is also called as subcooled liquids because at atmospheric conditions, the boiling temperature, saturation temperature is 100 degrees centigrade. So here the given temperature is less than 100. Therefore, it is termed as compressed liquid. Let us come to second case. In state 2, at atmospheric conditions, pressure and at atmospheric pressure, that is 1 atmospheric pressure, and temperature is 100 degrees centigrade. Water exists as a liquid that is already that is ready to vaporize. So this kind of liquid is called as saturated liquid. This kind of liquid is called as saturated liquid. Next one is a third case. If you see, case of third case, as more heat is transferred part of the saturated liquid, some portion of the liquid will be vaporized. So that is a saturated liquid vapor mixture. That is a saturated liquid vapor mixture, where dryness fraction is one of the important parameter to describe the quality of the steam at this point. So in this case, the dryness fraction of the steam is 0 in this case. Next one is at 1 atmospheric pressure, the temperature remains constant at 100 degrees centigrade until the last drop of the liquid is vaporized. So here, if you see at 100 degrees centigrade, the completely vapor is there. That's why the vapor is called as a saturated vapor. So the condition of the dryness fraction of the steam is called as 1 in this case. Next one is last condition, that is as more heat is transferred to the water, the temperature of the vapor starts to rise. So here 1 atmospheric pressure, the temperature is 300. So the atmospheric conditions, the boiling temperature or saturation temperature is 100 only, but it is heated more than 100, that is 300 degrees centigrade. Therefore, it is termed as superheated vapor. So like this, based on the condition of the temperature and based on the condition of the vapor pressure, we can describe the pure substance would be condition will be compressed liquid or subcooled liquid, saturated liquid vapor mixture, or saturated vapor, or superheated vapor. So like this, we are describing the condition of the liquid or vapor in case of phase change process. I am stopping here. Ma. Tomorrow also we will discuss the pure substance only in detail. Any doubts, Teja? Teja, Lokesh, Ganesh, anyone?
Sir,
Any
no doubt, sir.
doubts?
No doubt, sir.
Any doubts, Ma? You can ask me.
Meeting.
Lokesh,
Sir, Sir,
Narasimha, tell me, ma.
no doubt, sir.
1 second. My voice is not listening to me. Yeah, tell
Sir,
me. Yeah, tell me, Lokesh.
no doubt, sir.
Okay. I will stop here, ma. Tomorrow also we'll discuss the same thing only. It is time for me to attend the meeting. Thank you. Thank you,
Okay, sir.
Varandal, ma. Okay.